Welcome back, everybody. We are very excited to have you here for day three of 5 out of Clean Water Fest 2020. We're happy to have you here. We are glad you are back. Perhaps you're joining us for the first time. We're excited to have you here. My name is John Gonzalez. I work in our communication department. You can call me John G at NEORSD. You may know me from our social media efforts, and we are very glad to have you back for day 3. If you want to join us for this conversation, we are streaming live on Facebook right now. We're streaming live on YouTube right now. We are streaming on cleanwaterfest.com right now. And so we do hope you will pay attention. Hope you'll join the conversation and share this with your friends. Let somebody else know that you have tuned in, you are watching this, and we're hoping you are finding something of value here today. We've got a huge day today. Today is going to be our largest live panel conversation with our biggest group of employees so far here this week. And so I don't want to waste a lot of your time by blabbing on for too long. I want to get right to that. We're going to hear from several of our experts from our tunnel projects, our Project Clean Lake. Some of them are going to give you some perspective on what's going on underground and why we're doing the work we're doing. We'll also talk to you about the trucks and the tools that are being used by our sewer maintenance team and how they go about managing and maintaining the sewers that people are using every single day across our region. And we'll also look at the fleet that helps to get that work done. We'll talk to the manager of our fleet services to give you some perspective on the vehicles that we use and what work that takes to manage that team to get from point A to point B all across our region to make sure that the teams who are on their job and on the ground are getting the work done that they need to do. So with that, I want to turn you back over to our first feature video for today before our panel discussion. Today, our video feature is our sewer system maintenance and operation team. We are excited to showcase this video and debut it with you here momentarily. So again, if you are watching live, you can chat along with us at NEORSD on Twitter, #CleanWaterFest. We hope you are joining us and join that conversation. So as you will stay tuned, we're going to transition over to our featured video for today and get that started with you right now.
SSMO stands for Sewer Systems Maintenance and Operations, and our department is in charge of dealing with, inspecting, maintaining, fixed regulating assets, pump stations, CSO outfalls, and netting facilities within our service area. Right now today, we have 2 of our groups working together. We have members of our field crew with our crane and crew truck here. Last night we had an alarm that we had a low hydraulic issue, and we have crew members preparing to go down and do an assessment of what's going on there, look for any leaks, damage, to do some preventative maintenance, but also do some corrective maintenance on what our issues going on right now. So right now our sump worker is about 50 feet underground right now in a man basket, and he's conducting his inspection of the gate structures that are located under here and all the connecting hydraulic lines that go up to a control vault.
So via cellular connection to our treatment plants, we can tell what levels these gates are at through a control structure here, which is known, we call it a dry vault, which has all of our hydraulic controls, electronic controls, and all that stuff communicate back to the plants so we know what's going on here without even being here. But in order for that to work, we have to come out here and do our preventative maintenance measures, which involve taking this crane and lowering our people down there to check things.
How you doing? I'm Nate, Sewer Systems Maintenance Operations. I'm an FTO, Field Tech Operator. This is our video truck.
Over here we got the Rover X. It's one of our main keys to inspecting sewers, finding out what's in a blockage so we can come back with our jet truck and clear the block.
It's just a pretty handy tool to use without having to actually send somebody in some of the pipes because, of course, we can't make our bodies no smaller. So,
a big one is the wipes. Everyone says that they're flushable, but I'm not too sure about that yet. You'll see them in multiple blocks. You find a lot of different random things in sewers that you wouldn't think were supposed to be there.
And that's that's actually what that truck right behind you does.
My name is Alfred Harrison, Field Tech Operator. You could say This gap back here, our sewer truck, is the Cadillac of sewer trucks. We need to have the power in order to get the job done. And this truck here has plenty. This is a 100-gallon per minute machine, which puts out 2,000 PSI, which is plenty to get the job done. So when we need power, we have it.
A little over 51 years ago, the Cuyahoga River caught fire for the last time. Day in and day out, the men and women that make up the sewer system maintenance and operation department, they work tirelessly to ensure that history doesn't repeat itself and we can keep this natural resource, our Great Lake, great.
So as we come out of that video, we're going to transition and bring some of our panelists in here. So be patient with me as we bring them on. We've got 7 employees who are going to be joining us for our broadcast today. So I'm going to bring a few in at a time to introduce themselves and tell you a little bit about their work. I'm excited to bring on this variety of employees with a lot of skills, talents, personalities, perspectives, and really give you some insight about what it takes to manage the system that you saw here on display in our SSMO video. It's representative of just a small sampling of the kind of work that goes on and what it takes both on the surface and underground to keep our system functioning properly. So first of all, I'm going to bring on Doug Gabriel. He is the Deputy Director of our engineering and construction team. And so he works very closely with a lot of the construction projects that are going on as part of not only Project Clean Lake, which we'll hear a little bit about, but also a variety of projects across the sewer district. And so Doug, thank you for joining us.
Good afternoon.
With Doug, I also want to bring on another Doug. This is Doug Lapata. Doug Lapata works very closely with Project Clean Lake as well. And he will give you some explanation about what combined sewers are, how they function in our region, and how we are trying to meet those challenges that combined sewers have here in our region moving into the future. And so Doug, if you can turn your camera on for us and join us. Doug, good to have you here. Thank you for joining us. So Doug Lapata, let me start with you. Before we bring on the other panelists, I want to make sure that we have a little bit of understanding here about Project Clean Lake. To do that, we need to kind of look back at the urban water cycle conversation that we had with our viewers a couple days ago. Tell us a little bit about what combined sewers are, because that really sets the stage for the kind of work that we're doing right now and have been doing for a long time. What are combined sewers? What's a combined sewer system? I'll bring up some graphics here to help you explain, but give our viewers a little bit of explanation of what that is.
Yeah, so combined sewers, John, are basically the sanitary pipe is in the same pipe as the storm sewer. And so the sanitary and storm have a chance to mix during wet weather events. So what you're looking at here is a graphic of a typical combined sewer overflow regulator. And that upper trough really has the dry weather flow or your sanitary flow in it. And that's all going to the treatment plant during dry weather, no rain. And then when it begins to rain, we have a certain amount of capacity that still goes to the treatment plant before the capacity overtops the concrete weir or that ledge in the regulator. And then when we get larger events, it does happen to spill over this weir and it goes out to the environment through that lower pipe. And that's what we call a combined sewer overflow event.
Now, combined sewers have been around the region and under our region for a long time. This is how they were designed. They were designed with those relief points. Correct, Doug?
Yeah, and at the time, that wasn't a terrible idea because then a lot of the stormwater that runs off the streets and has pollutants in it from just being on the street does get some treatment at the plants. It was only when the impervious surface in the city kind of expanded from the core, Cleveland's core, out to the edges of Cleveland and into the suburbs, and all the parking lots and all the impervious surface kind of continued to be developed, is when that runoff became too much, where we had these overflows way too frequently.
And so really our solution towards addressing a lot of those problems is what we call Project Clean Lake. It's been a program that's been underway now for a number of years. What is Project Clean Lake all about, Doug?
Right. So Project Clean Lake is a 25-year program that's designed to control our CSOs to a level agreed upon with the EPA. And so we're going from 4.5 billion gallons of sewage going out when we started the consent decree in 2011. And then when we finish in 2035, we'll be down to under 500 million gallons, or 400 or so million gallons each year.
And so those solutions take shape in a lot of different ways. A big component is actually visible behind you in the graphic you have behind you as tunnels. Can you say a little bit about how tunnels are part of that solution?
Right. So one of the main component of the program is 7 deep tunnels, and these tunnels range from 100 feet deep to 200 feet deep. And essentially these are like offline storage tanks. So the flow that normally used to go out to the lake through the existing outfalls that got the rainwater and sewage away from the city, we build structures, concrete structures on those to drop the flow, 200 feet deep, and we store it in a tunnel. And then we build a pump station, or potentially by gravity, those tunnels drain back into our collection system and then go through our treatment plant to get full treatment instead of going out to the lake polluted.
And so we'll take a look at these in a few moments here, but I think the graphic on screen gives you a perspective of how many of what those 7 tunnels, where those 7 tunnels are located. How do they work in terms of the scheduling here? These can't all be built overnight. These can't all be built in a short period of time. Project Clean Lake takes 25 years. How did the tunnel construction, how is that spaced out over that 25-year time frame?
Yeah, so we did want to look at how we built these tunnels and not overwhelm both our internal staff as well as our contractors that are building these things for us. But we started on the east side, and the first tunnel was the Euclid Creek Tunnel. That is built and active. Then we built the sister tunnel, which is known as the Dugway Storage Tunnel. Same diameter. We basically used the same equipment, turned it around, and went south. So that one is done and active on the east side. And there's a big pump station associated with those 2 tunnels that's currently active. Then we moved to the Doan Valley Tunnel, which was to the south. That's kind of in University Circle. That one actually feeds flow to the Dugway Storage Tunnel. And then we moved over to the west side to the Westerly Storage Tunnel. That one's currently in construction, about halfway done on that red squiggly line there. And then we're currently designing the Shoreline Storage Tunnel to finish off the easterly system in green. And then next we'll move to the Southerly Tunnel, and the Big Creek Tunnel will be the final tunnel in the program.
And so this is just this is a major component of Project Clean Lake. There's other elements that we'll talk a little bit more about on Friday, including some green infrastructure opportunities and how they fit into Project Clean Lake as well. So we'll hear more about that later in the week. Doug, Gabriel, as I transition to you here for a moment, I wanted to ask you a question regarding the work that goes into putting a map like this together and seeing how all these pieces have to take shape, how all these pieces have to come together at the right time, and being able to construct these tunnels over this period of time. That's a tough process to manage. There's a lot of relationships both internally from a design side, there's the construction side of things, and there's the operation and maintenance side. I think that speaks to where we're going also with our video feature for today. So how do we go through that process from design to construction to operation and maintenance? We've got to make sure that all parties are connected all the way along the line. Is that correct?
Oh, yeah. So, these projects don't happen overnight. I mean, the Euclid Creek Tunnel took 3 years to construct. And then the Dugway Storage Tunnel was another 3 years to construct. There was some overlap between the two. But it's a huge team effort. It's a huge collaborative effort with all the various the parties that are involved. So the first part of it was to make the transition and get Euclid Creek tunnel construction started. And that was back in 2011. And we set up our field office out at 9 Mile. And we started the work there, clearing that area, and then finally getting Euclid Creek Tunnel underway. And as that occurred, then it was time to start to involve SSMO and bring them in and start to talk to them about how we're going to do that. and then how they were going to maintain it and how they were going to access structures, you know, and what equipment were they going to use, excuse me, and then where were they going to stage it in the road. And that it just evolved as we kept going through, and then we went through the same process on the Dugway storage tunnel, and now we're having those conversations on the Doan Valley Tunnel and the Westerly.
And so what I also want to be able to share is a closer look at what these projects look like as they're coming together. So Doug's got a great picture behind him that will kind of show some highlights of what that looks like and what the projects, what they look like on the surface as well. So I wanted to be able to share a couple images here with you as we kind of continue this conversation and bring SSMO at the table as well. So this project here is our Westerly storage tunnel. Is that correct, Doug?
Yeah, this is the Westerly site over on Scranton Road. This is just underneath the Abbey Road Bridge. You can see how this has evolved. So you have the shaft kind of in the lower section of the picture. That's the vertical conveyor coming up that's bringing the tunnel muck up to the surface as the machine progresses. And then that is stockpiled via the conveyor where the trucks are taking that material out to landfill. In the right-hand side are the precast tunnel segments that are being erected as the TBM progresses. So those are constantly being fed down that shaft. And then straight ahead, that straight looking thing from the shaft there in front of the crane is a cassette. And that holds conveyor belt in it. And that holds about 1,800 lineal feet of conveyor belt. So as the machine progresses, it's taking that belt with it. And then once it's used up, everything that's in the cassette, contractor comes in and reloads it, makes a splice in the conveyor belt, and off they go again. So there's this constant production and this constant movement of stuff there on the site. Tunnel muck trucks are probably leaving every 3 minutes throughout the day.
And this is just one of those 7 tunnels. And the reason we began with this aerial footage, this aerial photograph, is to show the size of the footprint that's required to embark on these types of projects. So it requires a lot of coordination with the community, a tremendous coordination here with our engineering and design team. And it's what most customers will have their closest experience with as this work is going on. They see what's going on above the surface. Very rarely will they see what's going on underground. And so these projects dig hundreds of feet underground. And this is just a look up one of those construction shafts, the access shafts that are dug to continue this work underground. And what happens as the tunnel is being built, the tunnel is being assembled piece by piece of those concrete panels that you spoke to, Doug. This is the lining of a tunnel as it's being dug underground, correct?
Correct. What the machine does is it advances in 5-foot increments. So it will mine 5 feet of rock in the case of the tunnels that we've done to date. And then once that 5 feet is done, each one of these tunnel rings, or what the tunnel 6 tunnel segments make up a tunnel ring, and it's 5 feet deep. So the machine advances 5 feet, it stops, it then erects the ring, and then it starts its next advancement. And as it's advancing through the back end of that machine, it's injecting grout between the newly erected ring and what it mined. So the annular space is filled with a quick setting grout. So that grout will set up in about 20 seconds as it's being injected in, and that allows it enough that it can support the weight of the TBM as the TBM advances.
And for those of you watching, this is a 20 plus foot tunnel that we're looking at. So if you were to be looking up trying to see how high the ceiling of this tunnel was, you'd be looking at a 20-foot diameter tunnel, and it's impressive. The tracks in the middle are used for a legitimate train car that takes crew members back and forth along the tunnel towards the tunnel boring machine to get them to where they need to be. And it's representative of the sheer size of what's being built underground and the volume of water that these tunnels can hold on to and be able to move through our treatment process during heavy storms is a tremendous relief and being able to reduce the amount of overflows going to the environment. And that's what these large tunnel construction projects are all about. So I appreciate Doug and Doug giving us some baseline understanding of what Project Clean Lake is and how these construction projects are helping to address some of those overflow problems that we spoke to in the past. The next members of the team I want to bring into the conversation are members of that sewer system maintenance and operation team that Doug spoke to in terms of the operation and maintenance of these tunnels. How do we go about managing these and being able to put them into activity once a construction project has wrapped up? So I'm going to bring a few people on one at a time. First of all is Mike Zapier. Mike Zapier, you may see him from some of our past videos, and he has done some work helping us to share the story of what goes on underground, how we go about managing our maintenance and operation of our sewer system underground. So Mike Zapier, Mike, could you introduce yourself, please?
Yeah, good afternoon. Here. I'm going to work on my video here, John.
It's all good. You go ahead and bring your video up. We'll bring on the other members of the team here. And I'll start with a question with you, Mike, in a second. With Mike, I also want to bring on Joshua Dress. Josh is a supervisor along with Mike on Mike's team. And so I want to bring him on board. And so Josh will be joining us. In addition to Josh Dress is another Josh, Josh Jeffy. Josh is a member of our team here. And you may know him from our past Super Bowl broadcast. Josh is the voice behind our Super Bowl broadcast with his colleague, Sean Austin. And we are very happy to be joined by Sean Austin as well. So I want to ask each of you some questions here in progression, because we're going to walk through some of the elements that Doug and Doug spoke to regarding sewer maintenance and how it relates to Project Clean Lake specifically. So Mike, as SSMO manager, let me ask you, generally speaking, what does sewer maintenance look like? We saw the pictures of these finished sewer linings. We see the video of what's going on under the surface. But when you look underground, what does sewer maintenance really look like for your team? Check your mic. Unmute for us, Mike. There we go.
There we go. Thanks.
All good. No, go ahead. Give us
now,
some
with SSMO, you got Doug and Doug. They design and construct these projects and these sewers. But what we do, our job is to operate and maintain the collection system. In other words, get all the flows to the plants. And our main focus is maximizing storage and minimizing overflows to the environment. But underneath the ground, what you see from our operations and maintenance, you've got tunnels that are ranging up to 24 feet in diameter, but we also have pipes that are only 8 inches in diameter. So we got large pipes out there and small pipes out there. So our challenges of operating and maintaining the infrastructure, we have a variety of equipment, variety of vehicles and stuff to get out there. And we kind of see what other communities have for smaller, and we see that, and we see the big infrastructure too. So.
Well, you mentioned vehicles. I want to bring on Ryan Exum. Ryan is our fleet services manager. So I want to bring him into the conversation because we will be speaking to a little bit about our fleet vehicles and how they contribute to the work that you're talking about. Let me bring Josh to the table then to ask a little bit about what that looks like. I'll have a couple pictures here on screen, but Josh, between the two of you, how do storms affect our sewers? We're coming off a very, very heavy, significant rainfall event that took place here a couple of days ago. So if you're watching this in an archive format, recognize that we just came off of a very heavy storm just 2 days ago, and our sewer maintenance team was very closely related to the work that was taking place afterwards to check on our sewers and to make sure that the system was functioning properly. What does that work look like, Josh?
So for us here in SSMO, an event like we had on Monday with historic levels of rain bring up a wide range of problems that could come up in the system. Things that we expect, have planned for, that we have protocols in place to deal with, and we have that process there. Those are some of the knowns. It's a matter of we see a rain event like that, we could kind of see these things happen, and we'll talk. I know we'll hear a little bit in how we monitor what's going on in the system with our flow tech, Mr. Austin. But with what's going on there, we have crews on site that are addressing these issues, that are seeing what's happening in the system, and then we're taking on the unknowns that are coming in. Josh was was here at work in the field as one of our crew members that was called in. And I happened to be the on-call supervisor that would be fielding alarms and getting calls from our southerly security team, who's getting calls from, the Cleveland Police Department of blown off manhole covers throughout the system. So there's all sorts of things that are going on. So it's important for us and in our group of people here and our guys that, work in our field crew. It's, being able to adapt and be flexible and address these problems in a timely manner, a safe manner, not only for our workers, but just the general public with blown off manhole covers and rapid flooding. So there's a lot of things that we just have to be able to move. We have to stay mobile. We have a wide range of skill sets in our department, so we're able to address these things as they come up. And I think that lends itself to the whole thing of what we're doing here, what we're working on the system, how we're monitoring the system, how we're getting around in the system with Ryan here and all the work that Fleet Services does, and Josh here for what our people are doing in the field in these events. So a historic rain event with with really good work from our crew, and I'm sure Josh can get a little more into maybe some of the things that he saw and experienced in the field, and how he goes about his daily work.
Yeah, and as we saw in the video, there's a lot of work that goes on that's maybe preventative maintenance. We've got a lot of responsive work that you're speaking to, Josh. So Josh, Jeffy, I'll have a couple of images here on screen if you want to just kind of use these as a backdrop. But the reality is, what happened on Monday was really exemplified the work that is critical to making sure that we can manage for the proper response to storm events like that. What does that day look like for you, Josh?
Yeah, and if you're looking at the picture, that's a good example of preventative maintenance that we do as a department. It's because of the work like that we do that, the system, when a huge storm like we had on Monday happens, the system works as well as it could. We did have some issues, obviously, but when you have that much rain, I'm actually currently at the Edgewater. At the Flapgate that, it was all over the news and social media about the Flapgate opening up and all that combined sewer overflow going into the lake. But because of all the preventative maintenance that we do with all the tunnels and everything that we're doing here at the district with Project Clean Lake, that Flapgate only opens 4 or 5 times a year when it used to open up dozens and dozens of times. Yep. So like Josh Dress said, I was here on Monday and just seeing the effects. Long after that Flapgate opened, our responsibility as sewer district employees is to inform and help the public and let them know that, hey, this could be a public health risk. So, we were here informing the public, giving them the knowledge about what an actually sewer overflow is. So that video that was posted, that shared, I think is very important. It's a vital thing to show of the work of the system and how it works, and people get a really good idea how that is.
Yeah, and so a lot of our social media efforts are really aimed at that point, Josh, and speak to a lot of the efforts that have already been brought up in our conversation, is to bring that to people's attention. And they usually aren't aware of issues like this until it affects them directly. And the reality is that all the work that we do affects our customers in some way. And we're happy to inform them and be there to answer questions and help them see what direction we're going. The construction that is underway right now with Project Clean Lake and the work that's already been taking place is really about solving a lot of the challenges that have been brought up. Just as we showed the aerial photograph to give a perspective of what the surface work looks like for our construction, this is going on the surface as it relates to preventative maintenance, Josh, but there's a lot going on underground as well that people may not recognize is happening. This is a picture I know that you had sent us a while back, and we've shared it on social before. It's certainly dirty work that is necessary to get the job done from a sewer maintenance perspective, isn't it?
Yeah, I mean, this is a little bit of an extreme case. It was awesome working with the crew that we had that day. This was actually at one of our Euclid Creek storage tunnel control vaults. So this is actually Green Creek. The actual creek flowed in here in this structure for a long time. So we actually removed, I believe the total was 250,000 pounds worth of just material debris from the creek, grit from the combined sewer. And this was a long project that we worked on. It was a lot of hard work, but we ended up cleaning it all up, and that structure works freely. It's doing its job. And after a rain event that we had, we do go out there as a crew and just maintain the structure. There's a couple bar rack structures that its main job. There's actually 3 that collect floatables, grit, and keeps majority of that stuff from heading into the Euclid Creek Tunnel.
And so after the storm, you're reacting and trying to eliminate these problems and make sure that the system is functioning properly. And it leads me to one of the other photographs you had shared a while back. The rainbow does look good after the storm, and there's always hope, and there's trust in the team that's doing the work. And it was a photo that I always like to share, and it's a good one for me to represent what our work represents in the community. So I want to transition back to Doug to talk for a second about a little bit more about the rain event. There was a lot of impact that took place across the region with the storm, and Project Clean Lake is well underway of trying to address some of those challenges, and we still have a long way to go. How are we going about seeing progress that has taken place since Project Clean Lake began 10 years ago? What are we seeing that is evidence that we're making improvements here over the last 10 years?
I guess I'll start, with the 2 tunnels being active on Euclid Creek and Dugway. We had a neighborhood that was built off of the Lakeshore Boulevard area up in the very northeast corner of our system. And this one's probably the perfect example of progress because they used to flood in a lot of events, maybe 10, 15 times a year. And we get calls from the residents, the councilmen, all others. And since we activated Euclid Creek Tunnel, we've received 0 calls from that area, and that's great news. And we're really pleased to provide that kind of service to that neighborhood. We actually missed the councilman calling, so we'll see how the other areas, there's a bunch of other areas around there that also, received improvement, but they were more kind of the overflow, and we're seeing a little better readings at the beach. When some of these storms used to dump a bunch of pollution out at Euclid Beach, Villa Angela Beach, we're seeing improved numbers there. So ultimately, all this stuff is really going to be a lot of progress once we're able to turn it all on.
So let me talk about, you referenced several different numbers there. I want to talk numbers for a second with Sean Austin. Sean is a flow monitoring technician. And again, he has spent time talking with us in our Sewer Bowl podcast, and we look forward to doing that again in the future. But Sean, numbers mean a lot to you, and we don't have people in the sewers tracking these numbers every day. A lot of it is done remotely and using the technology at our disposal to see how our systems are functioning and how they're operating. Tell us a little bit about the work that you do and how it contributes to the work that is going on in SSMO as well as our operations side.
Yeah, thank you, John. With the flow monitoring group, we support SSMO with a 3-tier maintenance process. And that 3-tier maintenance process is pretty much what Josh Jeffy touched on, the preventive maintenance aspect of it, where it's more of a time-based maintenance process in which we can maintain things proactively. And then there's predictive maintenance process. And that maintenance process is which we use our technology-based information to determine the condition of the asset in its current state. Then we have more of the reactive, where we have a corrective-based maintenance process in which those assets are repaired after by our field crews, or we may go in and repair our ultrasonic sensors or pressure transducers, whatever mechanism we may be using to monitor that particular asset. So those are the 3 main processes in which we typically function on a day-to-day basis when we're checking screens. And we also have another process in which we monitor projects. Right now we have the Stickney Creek project going on, and projects for watersheds and ENC and various departments where we support them as well.
Yeah. And so I'm glad you mentioned that. That's another preview of what we're going to talk about on Friday. Friday is our field day, and we're going to go out with a stormwater team and also our watersheds team to talk a little bit about what work is going on there at the stream level. It's not just sewers, it's streams as well. So I'm glad you mentioned that, Sean. And so as a flow monitoring tech, kind of what does your day look like?
Well, we have a 70-30%, balance. We do 70% of our work is in the field. Another 30% of our work is in the office. And when we're in office, typically we start our day off by monitoring screens on the portable side. our sumps do the permanent side, and our supervisors actually monitor those screens. But the flow monitoring crew, we'll monitor screens early in the morning. If we see any issues, we'll communicate that with our supervisors in SSMO. And then from there, we'll do site PMs, we'll do site investigations, and then more intel work. We'll do equipment installs, we'll do survey work as well, taking topo reading and elevation readings and things of that nature. And we'll also assist with Ohio Utility Protection Services as well.
Very good. I'm glad you mentioned those relationships, because I think that really speaks to what question I want to lead into a quick discussion with Ryan Exum. So Ryan is our fleet services manager.
Mhm.
And if you've seen anything in the conversation thus far today, you've heard a lot about the relationships in the work process, how we move projects from start to finish, and how we transition them into operations. Every department that's represented in this panel here today relies on the right equipment and having the right team in place. Our fleet services team, and you saw vehicles of all kinds showcased in our brief introductory video. Ryan, how important is it to manage our fleet with the right equipment to make sure we can support our departments as needed?
Thank you, John. It's absolutely essential. Fleet services, we maintain 172 licensed road-going vehicles and 118 specialized off-road vehicles. Our number one mission at Fleet Services is to be sure that our field crews have the equipment in proper, safe working order, ready to go at a moment's notice. As we all saw with the storms on Monday, things can change in an instant. Weather can change, and that vac truck that we saw pictured, when we need it, it needs to start. When the power goes out, the backup generators need to start. Our number one mission is maintaining every piece of equipment the district owns with a fine-tooth comb to ensure that when we need it, it's ready to go.
And you mentioned that key number of how many vehicles are in the fleet. So a combination of vehicles, almost 300 vehicles we used in one of our trivia questions before the broadcast began. Another one of those numbers was 1 million. Ryan, is it true that our fleet services team drives almost 1 million miles over the course of our service area in a given year?
Yes, it is.
Yeah, so the amount of effort that goes in, the amount of gas that gets used, but more importantly, how much effort goes into maintaining this fleet. If you don't have the right equipment, if you don't have the right staff on hand, things can be affected down the line, correct?
Absolutely. And, it's we're very fortunate. We have an outstanding staff of fleet service technicians. All of these vehicles are maintained with 6 technicians. And, combined between those 6 technicians is 216 years of combined experience. Very diverse backgrounds, automotive dealerships, former school bus technicians, heavy equipment technicians. The average experience level of a fleet services technician at the sewer district is 34 years. It's essential that no matter what comes through the door, a utility truck, a vac truck, a hydraulic excavator, that we can fix it quickly, efficiently, and correctly the first time so that it can go out and do its job.
I think that's a good way to wrap up our broadcast for today. You've heard from a lot of those diverse faces, a lot of those diverse skill sets and backgrounds to really speak to our accomplishing our mission, protecting our Great Lake, protecting public health and the environment, and the amount of skill that is necessary to keep that going, keep that work functioning properly day after day is on display in today's panel and throughout the week. Clean Water Fest tells this story, and we are glad you are joining us here today. We hope you've tuned in the last several broadcasts. We've got 2 more to go after today. Tomorrow's broadcast will really be focused on a Clean Water Kids Day. We'll get to hear a little bit more from our mad scientist duo in the lab. We'll also see what kind of work is going on in classrooms to help to tell the story of what clean water means to kids of all ages. And as was kind of previewed with a couple different comments today, on Friday, we'll also hear a bit more about what work goes on in the field, whether it's with our stormwater team, our watersheds team, our green infrastructure work that's going on. There's things happening in your community, in your backyards, and some of them some of those people were here on display today, maintaining those sewers on your streets, in the parking lots, and making sure that the system is functioning properly. For all of you, I want to thank you for joining us, and thank you, members of our panel, for being here today. A couple other resources I want to make sure you're aware of. We have a lot of resources on our cleanwaterfest.com website. So if you want to learn more about tunnels, if you want to learn more about sewer maintenance, we do have great video clips and additional resources that are available on our website, on the day 3 page of our website, cleanwaterfest.com. We do hope you'll check that out. Join the conversation with hashtag cleanwaterfest on Twitter, and we will be looking forward to you joining us tomorrow. So for all of us here at the Sewer District, for those of you who are on the panel, I want to thank you again. Look forward to tomorrow's broadcast. And for those of you watching, stay tuned, and we hope to see you again tomorrow. Thank you very much.